Hello everyone, welcome to exercise number 2. This video will include 2 short exercises where we explore a few of the GIS tools and procedures from our previous lecture. For exercise 2A, we will conduct some simple analysis with the same data from exercise 1, a shapefile of community forest in Liberia and a land cover map of Liberia. Our goal for this hypothetical project is to compare the land cover both outside and inside community forests of a certain size. In our case, we're looking at community forests between 10,000 and 80,000 square kilometers. For exercise 2B, we will learn to create and digitize shapefiles manually. So here we are, back at the QGIS interface. Just like last time, we're going to add our community forest shapefile and the Liberia land cover raster. However, this time, instead of clicking on the Add Vector or Raster button, we're instead going to the browser panel and directly dragging the files that we want into GIS. And again, the objective of this theoretical exercise is to only look at the CFs between 10,000 and 80,000 square kilometers. To do that, we could use a query on the community forest shapefile. To open up the attribute table, you right-click on the CF shapefile. Go to Open Attribute Table. And in this table, you see the names of each of the community forests in one column, and also the areas in meters and kilometers squared in the others. We want to click on the Select Feature using Expression button right here. In this expression box, we want to write an equation so that only the CF smaller than 80,000 but larger than 10,000 is selected. And to do this, we click on Field and Values, double click on Area, make sure it's the right one with the kilometers squared, and go to Operators, which are where the logical operators are. Choose less than, type in 80,000, add and do the same thing with greater than 10,000. Now press select, and you can see on the map that, and on the attribute table, that the ones that are selected that meet the criteria that we put into the expression box are highlighted yellow over here and over here. After the correct CFs are selected, we want to create a new shapefile with only the CFs that we selected. To do that, right-click on the layer, go to Save As, browse to a good location, and name the file with the relevant name. The important step here is to select this box, Save Only Selected Features. Press OK. And there you go. If I turn this layer off, you could clearly see that the new shapefile is different from the old shapefile. So now that we have selected our 4 community forests, our next step is to buffer the community forest to create a quote-unquote outside zone. For this step, we want to open the toolbar panel, which is located under the processing toolbar. And now we want to type in buffer in the search bar and select buffer vectors. We want to change the input layer to the selected CFs. Change the buffer distance to 1,000 meters. Usually the default unit for distance is in meters. And press run. And so you see here, if you drag the buffer below the CF, you can see that there is an outside buffer for around the 4 CFs. But if you look closely, you'll see that the buffers encompass all the area both around, outside, and inside the community forests. What we want is essentially a donut around the CF. And to do that, we want to use the difference tool. Type in difference in the toolbox and choose the buffer as the input layer. And choose the selected CFs as the difference layer. We want to save this in a good location. And press run. And so we have a new layer in the layers panel called difference. And difference is of course just a 1 kilometer buffer outside of the community forest. Now with our two different layers, difference and selected CFs, what we want to do is compare land cover between these two shapefiles. And the easiest way to do that is to clip the land cover layer with our two new shapefiles. The tool Clipper, which is located in the raster drop-down menu, can help us do that. And so we want to input our land cover as our input raster file. And we want to choose a mask layer as an extent. And we have to do this twice, both for the difference and for the selected CF shapefiles. Select a place to save it. And run it. Now some of you may have run into an error, as I did here. Now errors and troubleshooting are inherent parts of GIS. And because QGIS is a free and non-profit program, it's often more prone to potential errors. And usually a quick Google will fix your error. And in this case, reading the error, we know that this GMT output driver is not recognized. I gave this a Google and it seems like there is a fairly easy fix. And what we want to do now is click on this button so that you can edit the lines of code here and simply change this word GMT to geotiff. And that should work. Click OK. And the tool should start running. Now this Clipper tool, because the raster files are so large, it might take a very long time depending on how powerful your computer is. And so here we are. I skipped ahead a little bit. We have both of our land cover classes outside and inside the community forests. Now, working with QGIS, as I said, has its problems. In QGIS, you can't open an attribute table for raster data. An attribute table for either one of these rasters would be extremely useful since we could directly observe the percentage of each land cover. And so we're going to have to find a way around that. Now remember in the lecture we talked about plugins in QGIS. Plugins are the primary way that most people contribute to QGIS. And so I found a plugin that could help us with our attribute table problem. So if you go to the plugin drop-down menu, manage and install plugins, and type in LECOS, which gives you a plugin called Landscape Ecology Statistics. And I already have this installed, but go ahead and install that. And this plugin gives you access to tools that can help us with our attribute problem. And so in our toolbar, if we type in LECOS, we get all the tools that are within this plugin. And one of them, this one, count raster cells, is exactly what we want. This tool summarizes the raster and counts how many cells are in each land cover class. So double click that and put in both of your CF and difference land cover clips and run them one at a time. And so after that finished running, you'll notice in the layers panel a new layer called result output. And this is the output from the count raster cells tool. And if you right click on it, and you'll notice that the open attribute table option pops up. And so you want to open that. And so looking at the attribute table, you have two columns. Value, which is the land cover class, and number, which is the number of pixels. And from the number of pixels, you could derive the percentage that each land cover class covers. And you could also derive the exact area by multiplying the number of cells by the raster cell size. But currently, we don't know what the cell size is. We also don't know what each of these values, these land cover class values, mean, since they're just a number instead of the actual word. And so our next step is to find what's called metadata. Now, metadata sometimes comes with the data where you acquire it. Sometimes you would have to look online, do a quick Google search of your data for it. Sometimes it's given by the person who gives you the data. And so in our case, it was given. And so if you look at where our data is stored, there's a text document along with the rest of the raster. And so if we open that up, there's a bunch of information on the raster layer that helps us. And if we just scan through this, we see that this raster layer is an amalgamation of a Landsat and RapidEye data, and that the two data sources were merged into a 5-meter dataset. So 5 meters, in this case, is our raster size. If you scroll down, we get exactly what we were looking for. The legend of the value numbers and the class names. And so if we compare this legend with our attribute table, we could then know exactly what these numbers mean. And so we could even add these class names to our attribute table. To do that, we want to toggle editing mode, add a new field, which is a new column essentially. We want to name it class name. We want to change this type to text. And essentially just copy and paste these in so that it matches. Oops. Eight. And so we did this for the CF clip, which is the community forest, and we want to do the same thing for the difference, which is the outside of the community forest. And so I've skipped ahead a little. I have two tables here, one is inside and one is outside community forest, and we successfully completed our objective, which is to compare the land cover within and outside community forests. And that is the end of exercise 2A. Now I'm going to start exercise 2B, which is an extremely short exercise just to teach everyone how to create vector shapefiles. Now, as I said in the lecture video, creating vector shapefiles is a very versatile thing that you could do. You could use it for a variety of reasons. You could try to digitize features that haven't been digitally mapped, and you could also create shapefiles to help aid in your analysis. And so for our exercise, let's use this land cover map of Liberia. Usually when you're digitizing, you probably wouldn't use a land cover map. You would use, if you digitize, you might use satellite imagery or aerial imagery. But for our cases, as an example, I think this is fine. And zooming out, I think this is Monrovia. The red areas especially is part of the city. And let's just say we want a shapefile of roughly the area of the city. And so to do that, we go to the layer drop-down menu, create layer, new shapefile layer. And so we want to create a polygon around roughly the city of Monrovia. And so we choose polygon. We could leave everything else as the default. This is if you want to add certain fields or columns. So press OK. Now you have to choose a location to save it in. And name it Monrovia boundary. And so you have this new shapefile in the layer panel right here. But right now there's no geographic information. There's nothing in the shapefile. And so we want to edit that. We want to draw out and digitize our polygon. And so we go over here. We want to toggle editing for this layer. And right on the toolbar, there's a button called Add Feature. So we want to click that. And you see that your cursor changes to a circle with a cross in it. And so you essentially just click on the edges where you want to define the polygon. And essentially keep clicking. Right now I'm just drawing a very rough boundary. Depending on what you're digitizing, you might want to put more time and more vertices in. And when you're done, you just right click instead of left click, and it'll prompt you to put a feature ID down. Since it's our first shape for this shapefile, we'll put 1. And there you go. This gray shape is now your really rough boundary of Monrovia. And so we want to save our edits. Go back to the toolbar here. So save our edits and turn off the editing mode. And so there you go. You have your very rough city shapefile. And so we created a shapefile to delineate the city boundary. But you could also create shapefiles for other purposes. We created a polygon. You could create points and lines as well. If you're creating shapefiles for the repelled system, you might want points as plots, lines as transects, or polygons as modules. So that is the end of our second exercise. In our next video, we will go through some basic cartographic principles and teach you how to essentially make your map look better.